123, and my name is Xue Shi. My next street number is US02380, and our design is smart walking stick. And let me do the problem statement. Common blind stick provided in the market are naked in the ability to detect currently smart obstruction on ground and causing difficulties when climbing stairs. It may cause delay in decision making, especially when user is facing new surroundings. A smart blind stick should be designed to overcome said difficulties with added safety features. And then our objective is to design a smart blind stick which ensure the safety navigation to provide improving design based on common blind stick to assist user better when moving around obstacles.
Assalamualaikum, my name is Ahmad Rosli and my number 18987. So, previously we have said that our design has 3 designs, design 1, design 2 and design 3. And we choose design 2 because design 2 is the best after the evaluation. So I will show you this concept on this table. Okay, as you can see, the concept 1, the difference between concept 1, concept 2, concept 3. We have the concept 2, which the processor we use Arduino, and the output we use buzzer and the vibration motor. So, next. So this is the engine drawing for the design 2. As you can see, this is actually 860 cm length. 86 cm length. Basically, this length is for average height of the Malaysian adult, because our market study and our targeted customer is in around Malaysia. So the height is basically to suitable with the average adult in Malaysia. So next, so as you can see, we have 3 sensors that are processed by Arduino, which is we put the sensor at the below, at the middle, and at the top. The reason why we divide 3 sensors is because we want to have a full coverage of the 360 surrounding, and also we want to divide the weight so that when the patient who holding the blind stick, it will economic, so the weight not just fully pointed at some certain point. So basically that is just all about the design. Thank you.
Assalamualaikum. Hi, my name is Fateh Shada Rozi. My matrix number is 187354. So now I will be explaining the mechanism of the design. So from the previous design that we have seen, we have a blind stick, smart blind stick. So first we have the strap. Strap is to provide a comfortable grip for the user. Also rubber grip, skid resistance, and also prevent from electrical shock. So because we have a lot of wiring system inside the design, inside the board, so it doesn't really, it is unlikely to fail, but we just provide that feature to give more security to the user. So we also have adjustable pole for the cane, so the user can adjust the desired length for their own comfortability, and also to give a more storage space. Other than that, we have GPS tracker, so it can detect the current location of the user, and then in case of an emergency, the location and the time of all the details will be sent to the emergency contact. So other than that, we also have ultrasonic sensors, infrared and water sensor. We have 3 sensors located at the lower part, bottom and the upper part. So why we choose to do this is because that it can provide more coverage in terms of obstacle sensoring. So we have ultrasonic sensors, can detect sound wave, can detect obstacles like stairs or moving object. It can prevent collision. Infrared, it detects small obstacles like rocks or holes. And water sensor, it can detect wet surfaces. So that is exactly what we put at the base of the stick. So microcontroller, we use Arduino. From the sensors before, it will detect the input and send the input to the microcontroller to be processed, and then the process input will be sent to either vibrating motor or buzzer to produce an output in terms of either vibrational motion or auditory response. So vibrating motor and buzzer. Vibrating motor will vibrate even more frequently as the objects becoming closer, while buzzer will make a louder sound as it becoming closer to give the user a sense of direction, a sense of distance between the user and the obstacle. So basically, how the user use the smart walkie stick is that first the user can open up, either adjust the length, and then can use the walkie stick as usual. In case of an emergency, there's an emergency button, and then the space tracker will take this. Thank you.
Okay, so good morning. So I'll be presenting on the calculation part. So first of all, we have a look at the vibration calculation. So the main formula for vibration is the omega n equals to square root k over m. So we have to individually find k and m. So first we find the k. So the k is equivalent to F over x. So based on our study, we have found that the F is equal to 20 pounds, which we convert to Newton will be 88.98 Newtons. And we take the x as 0.014. Why 0.014 is because we assume that the deflection should be no more than half the diameter, smallest diameter of the stick. So hence 0.014. So we put into the equation, we make a calculation, we get k equals to 6,355.7 Newton per meter. We take that, we put into omega n's equation, k, and the mass is 715 grams. Yeah, if we look at previous lesson, so we make a calculation, we get the omega n, which is equal to 8.889 rad per second, and we convert it to hertz, will give us 13.96 hertz. And next we'll look at force calculation. So this is our free body diagram. So here are the details of all the forces that are on the free body diagram. Here I've shown the calculation to find the reaction at D, point D here. So I get about 84.62 Newton. Next. So this will be the diagram that I've plotted. So first here we can see that the highest force will be about 88.98 Newton, and it drops down as we proceed from A to D. It drops to 86.53, then 84.62. Next we'll go to 0. Then we have the shear diagram, moment diagram. So we start from 0 and go all the way up to 45.38, showing that's the highest moment, and it slowly goes down 41.05, then to 15.66. So next we have the buckling calculation. For the buckling calculation, the main formula is actually the Euler's method we've used here, which is P equals to pi EI over KL in whole bracket square. So we find each and every details, like E for our stick is made of poles, so the E is about 69,000 Newton per millimeter square. And then we calculate the moment of inertia I by using the outer and inner diameter. So the outer diameter is 0.014, the inner diameter is 0.010. Since our pole is a hollow cylindrical stick, its formula is like pi times d outer power 4 minus d inner power 4 close bracket over 64. So we just plug in the values and we get the I as 1395.05 millimeter power 4. Then we plug in this into the Euler's equation. The k here is chosen as 2, and the L is the length basically, which is about 860 millimeter. We convert it to we leave it in millimeter. The k is 2 because of it is fixed in just one part of the pole. So we plug in all those values, we make the calculation, and we get our P, which is the load, as 102.23 Newton. That's all from me. Thank you.
Okay, my name is Iman Afamul Mansur. My matrix number is 188867. Okay, behind me is the picture of the sensor, buzzer, and motor, which is this. If you can see, this is Arduino microcontroller. This is ultrasound sensor. This is water sensor. This is IR sensor. This is the buzzer. This is the GPS, and this is the motor, vibrator motor. Okay, next. As we can see, the minimum natural frequency that we get from this simulation is 37.974 Hz, which is from the calculation we get above the value is high enough. So we can see that if we compare the calculation, theoretical calculation, and the simulation, we can see that this pole can adapt with the minimum and this maximum, because the calculation for the theoretical that we get is lower than the maximum natural frequency that we get from this simulation. Next. Okay, then this is the simulation for the force reaction, which is we get the force for the simulation same with the theoretical calculation that we have get. So next. This is the total deformation that we can see this how the pole will deform when it is used, or it will be knocked at the wall or the road when the user use. Next, this is the equivalent stress simulation, which is we can see where the stress is more located. So we can see from that point we will maybe we can upgrade the material at that point which we can see the more stress, so it will be more less longer. Okay, next. Okay, for the conclusion, we have finished for the project design 2 project, which is for our project we do the blind stick, smart blind stick, which we can help the blind or deaf user. And we think that if this design is good, so I think we can help the disabled people to make their life more easier. So that's all from us. Thank you.